Hello students, welcome back to CLARIconcepts, Unleashing Conceptual Learning. Today in this lecture, we are going to solve the numerical examples of hydrostatic force on the curved surfaces. Again, I request you, if you have not visited our lecture on theoretical aspects of this particular topic, go and look at that lecture first and then come back to this lecture to solve the numericals. Otherwise, you will not be able to understand how numericals are being solved. So let us move ahead. The very first numerical we have is compute the horizontal and vertical components of the total force acting on a curved surface AB, which is in the form of quadrant of a circle of a radius 2 meter as shown in figure. So we have this figure, we have this around solid surface, solid boundary and the fluid filled within that. AB is a section which is of quadrant of a circle, so it is 1/4 of the circle with a radius of 2 meter, right? Take the width of the gate as unity. So when I say width means perpendicular to the board, the distance, the gate has a width of 1 meter, unity. So now, this is the free surface and 2 meter is the distance given to us, right? And it is also given that the free surface, the point A is lying 1.5 meter below the free surface of water. And now what I need to do? Simple. Solution. Just look at the steps. Firstly, figure out which section are you aiming at. So I'm aiming at section AB and I want to know the force acting on this section AB. Yes. So what you will do, mark the end points, mark horizontal line and vertical line from the end points, and then figure out the pocket of fluid filled between these two planes as well as the curved surface. So if you take this outside, you will see something like this. Very simple, isn't it?